I'm gonna talk about current events for a second before we get started. When I wake up in the morning, I like to start with just checking headlines, current events, see what's going on. And I caught one that said, let me get to the top here. It says, General Electric, 500 billion market wipeout is like erasing Facebook. So I had to see more of it because it gave me a flashback. Right around like 2007, 9, 10, 11, I used to, whatever class I was lecturing, I used to bring up General Electric's financials to show how their net worth is close to nothing. That they just owed so much money, that they're such a huge company. And then I remember in 2008 that big headlines, after the financial crash, General Electric was in trouble. And Warren Buffett, I don't know if you guys ever heard of the famous investor, Warren Buffett came in and said, I'll make you a deal. I'll give you $3 billion to help you make it through this crash, this financial crisis. But in trade, you have to give me preferred stock, brand new preferred stock with a dividend of, I can't remember the percentage, but we talked about it in class because this was such a big event happening at the end of 2008. So that when I saw this headline, I said, wow, I wonder if Warren Buffett got any of his $3 billion back, you know, or is he still, has he lost a bunch of money on this investment? So I started doing a search, and I think I put the words, this all happened this morning, GE Buffett investment, just trying to search so I could figure out, you know, how much was it, what was the percent, does he still own it, has he sold it? And I started seeing headlines from 2018. And I'm going, what's going on? Why is Buffett and GE together in headlines in February, March, right around January through March of 2018? And it's because Warren Buffett was being interviewed, and in the interview, whoever did it said, would you ever consider buying a whole bunch of shares of General Electric? And he said, sure, if the price were right. But then he kind of, from an article I read, he said after it, but I would do that with any company if the price were right. You know, he kind of was not being so specific with General Electric. But just those words where he said, sure, if the price were right, that day the stock went up about 6%. Now 6% doesn't sound like a lot to you maybe, but for one day, going up 6% is like unbelievable. Think about it, the stock went up 1% every day. I think the market's open about 300 days a year. That would be a 300% increase. This went up 6% one day, 5, 6%, something like that, 5.8. Unbelievable. And I caught that, but it still didn't answer my question. What happened to his $3 billion? I mean, they're talking about how, this article says, over the last 18 years, from 2000 to 2018, General Electric, its market cap, and I want to make sure you know what that means. If you took all the outstanding shares that exist times the price per share, that's a big deal. That's called the market cap. And they were $600 billion. Now, just so you can see what that compares to, I think about a year ago, Apple was the first company in the United States to hit 1 trillion market cap. And then I think Amazon may have been the second company shortly after to hit 1 trillion market cap for the first time in our history, so that was a big deal. At this time, they were 600 billion. Their market cap is less than 100 billion. That's a huge decrease, even though it's over a long period of time. Just kept me looking. This, believe it or not, this is heading to current events. All right. So I finally found the article I'm looking for. Is this it right here? And this is an article from 2008 that says Buffett's investing $3 billion in GE. But it's from 2008, so now it helped me remember that this did take place. I wasn't dreaming. I do remember this, and how much it was. But my real question is, did he lose money? Does he still own it? And GE's doing this poorly that he's down. Berkshire Hathaway is the investment fund that he managed for many, many years. So really, it's Berkshire Hathaway. But for those who don't know Warren Buffett, he's so famous as an investor, he has a nickname. And his annual meetings for his investment company is like going to a concert of rock stars kind of thing. It's like a big, huge event. And people come from all over to go to this once a year in a little Arkansas or somewhere. He lives like he's not even rich, and he's a multi-billionaire. So, anyway, he bailed him out. Come to find out, I finally found an article that says what the most recent news is. I don't want, hang on, I want to stay in order. Finally found an article, nothing around here, gotta find it. That says 10 years ago today, just a coincidence, this is true, October 1st is when this bailout took place of $3 billion. And where is it? Come to find out, he ended up, General Electric bought the preferred shares back by 2011. So it was only 8, 9, 10, 11, about 3 years, and they turned it around to the point to where they could pay him back the $3 billion. So he didn't lose any money, and he made, I think he asked for 10% interest on the money for those 3 years, each year, 10%. So they were paying some interest, and they knew it. Interest rates were coming down. They figured out a way to borrow money at a lower rate and pay him off. But the bailout, they would have never got the money at the time he bailed them out. They only were able to get the money 3 years later. So, long story short is, then the most recent news, I'm going, well, why is Buffett and General Electric in the news now? And this is just one thing after another, just because of one article jumping out at me. And it says where he has been upset with General Electric because they had to do what's called a write-off. He still owns some common shares. And so he spoke up, because when General Electric did this write-off at the beginning of this year, it means that they were reporting some financial information. Any accounting majors here? Raise your hand for accounting majors. I want to see where you guys are at. 1, 2, 3, that's all I have. 4, 5, just 5 of you. That's it? Well, I'm directing this to you now. The most important job for you accounting majors when you get into your business is you got to be the truth. You got to be the conservative, financial conservative voice at the table. You guys, about 10 years from now, a bunch of you are going to finally make it what I call to the table. And that means you're part of the executive team, you're helping direct the course of that company, and your goal is growth, right? And you're now involved in big decisions. And you're going to forget everything you've learned in this class, but then all of a sudden, now that you're at the table, you're going to realize how important it is that you start getting involved in helping that company save money. And the key for all of you to get to the table is to never, ever lie at work. And if you're an accounting major, your job is to always be the truth. That the numbers always have to be the truth. They cannot not be the truth. As soon as any company that's public, and it finds out that the numbers are not the truth, that's like the beginning of the end. You're heading towards bankruptcy. And many of you are too young to remember, but I started thinking, oh man, I hope GE is not going to go down to the count because of this false financial reporting where they have to do this write-off of millions of dollars. I can't remember the amount, but it reminds me of Enron. Does anybody remember the name Enron? Does it sound familiar to you at all? History always repeats itself, always. And if you don't start studying business history, you're going to end up 10 years from now possibly being in a situation where you're taking a ship down and not even realize how you got there. And that's what happened with Enron. It went down, and it went down fast because of inaccurate, lying numbers reporting. So accounting majors, whatever's going on at a company, you have to be the integrity. The integrity is the person who always does the right thing, even when no one's looking. You got to be the clear, conservative, truthful voice at the table when you get to that table, and make sure the company stays within the ethical standards. That's the key. Now, this all goes full circle, because last night I saw 60 Minutes. I don't watch TV that much. I just happened to catch 60 Minutes. Anybody see it? Not one person. Are we recording? Not one person, seriously? You guys. Current events. 2 senators from that whole fiasco that took place, was that Thursday and Friday? Is that correct? Or Thursday? No one knows what I'm talking about? The Supreme Court. Okay, Kavanaugh, the accuser. Did anybody even hear clips from that whole situation? You did, so you know that took place, right? We have a week for this prediction to either become true or false. But once in a while, I make a prediction because it gives me what's called the chill factor from something I'm reading or something. This is sometimes how I make investments. When I see something, an opportunity, all of a sudden I'll feel the hairs of my arms stand up. And I call it the chill factor. And that's when I go and dump money into that investment because I see something that I believe is going to come true. Right? That's called trying to go after the big kill. If you knew the Apple phone was going to be huge back before it came out, you would have made a ton of money. If you knew what's the phone I always talk about, the Motorola Flip Razor, you guys are too young to remember, everybody had to have it. Motorola made a ton. If you knew if you saw that phone go, oh my God, that phone gave me the goosebumps. I knew that had to be. The iPhone, it was called iTouch at the time. I got to play with my first one. I got the goosebumps. I had to invest in it. I knew everybody's going to feel this about this. My point is, I got the goosebumps when I put this all together, when I was reading this, because the Supreme Court person, I'm predicting there's no way it's going to become a Supreme Court justice. And it's going to be voted down when the week's up. And it's most likely going to be because these senators will not be able to vote yes when they find out that he lied in his statements to that committee. And that's what's going to happen. And that's my prediction. And that's why you should never lie, especially in your career. Ever, 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 ever lie. And that's the hardest thing for you to do. As humans, our first instinct is to not hurt someone's feelings or get out of a situation due to a lie. A lie comes easier to us than the truth sometimes. And so you have to internally concentrate and say, while I'm at work, I'm never going to lie. Because that accidental little fib that you thought was no big deal will come back to haunt you. And you will not make it to the table. And you'll not even know why you didn't get the promotion. And just live your career in the truth. Be the truth at the table. And things will come to you without you having to ask. Just be truthful and honest. And that's the whole point of all this. Don't be another Enron. Don't be another, what's the largest bankruptcy in our history?
Fannie Mae?
Say it again.
Was it Fannie Mae?
No, the finance company, a big, huge one, not gold, not, Merrill Lynch, not Merrill Lynch. Lehman Brothers. Don't be another Lehman Brothers. I can't believe I can't remember Lehman Brothers. All right, you ready? Chapter 2. We're going to finish it up. I'm going to review. We're going to pretend like this is an assignment. You were able to pull out this objective function and these constraints for the story, and now you're being asked to solve it using the graphing method. And you have to make sure, and it's going to say how many extreme points are in this solution. Identify the feasible region. Calculate the slack or surplus you're about to learn. Which constraints are the binding constraints? Calculate the objective function value. These things are going to be part of your answer. Well, it's for sure on your homework, and it's going to be probably part of your quiz. So, you ready? I did it on this paper here thinking this would be easier if I did it right here. First step. Can everybody see it? Not yet. Let me make sure this is on here. I'm going to focus. All right, first step is you need to graph your constraints. So I do set one variable to 0, solve for the other. Set the other variable to 0, solve. So I'm going to make all of this column A, all B. Tell me if you can see this. You see everything? We're okay? Go ahead, and I'm going to take the first constraint and put a 0 in for A plus 2B. I'm making an equal sign just because it's easier. Now I'm dividing both sides by 2, and I get B equals 3. It says when A is at 0, B is going to be 3. There's one spot on the vertical axis right there. Now I'm going to put a 0 in for B for the same constraint. A, 1A, plus 2 times 0 equals 6. 0 times 2 is 0. All that's left is A equals 6. So A equals 6. When B is 0, A is 6. There's our 2 points where this equation, if it were graphed, would cross the axis, the vertical and horizontal axis. Doing the next one now, same thing, put a 0 in for A, put a 0 in for B. 5 times 0 plus 3 times B equals 15. I'm going to, 0 times 5 is 0, divide both sides by 3. When A is 0, B equals 5. Is that right? Anybody else checking this? Now I'm going to put a 0 in for B. 5A plus 3 times 0 equals 15. I'm going to multiply both sides by 5. When B is 0, A equals 3. Okay, I could graph these now, but before I do that, since I'm already plugging in zeros, I'm going to now do the objective function, because I know I'm going to have to graph that also. So I'm going to say the objective function, I'm going to make A 0, and then I'll make B 0, but I have to make it equal to, so this is 2 times 0 plus 3B equals, I don't know. The other one's going to be 2 times A plus 3 times 0 equals, I don't know. So I got to look at this. And what I do is I look at my points that I know I'm going to be graphing for those constraints. I see 0, 3, 6, 0, 0, 5, 3, 0. On the horizontal axis, which is your A, the biggest it gets is a 6. And on the vertical axis, which is your B, the largest it gets is 5. So I kind of want, I know this is a max, and these constraints are less than equal, so I know the feasible region is going to be downward probably. And I'm trying to figure out a way to have my objective function go across it. So I say, well, what would I divide by 3 or divide by 2 where the answer would be 6 or 5 or less? So go through it. So 2 and 3 times 5, well, that's 15 or 10. Do they both go in 12? Let's see, one would be a 6, one would be a 4. So I could use 10, well, not 10. I could use 12, what else? What do I have, 2 and 3? 9, 12, I guess not 9 because it's not even. 12, 15 is not even. 18, I'm going to go with 12 for some reason. I don't know where I was going with that, but 12 looks good. Arbitrary number is the point. You can pick any number. And if you picked one too large and your objective function is way out of there, you still got the right angle. You just need a straight edge going in a different direction to find that optimal solution. So I divide both sides by 3. B equals 4. So when A is 0, B is 4. Divide both sides by 2. When B is 0, A is 6. Now I have everything. I'm going to graph. Let's see. Where can I do this? Oh, right over here. I know my numbers have got to be 6 is the largest. I'm calling this A. So 1, 2, 3, 4, 5, 6. I'm trying to make my spacing evenly apart, and as even on the vertical axis, which would be our B axis. 1, 2, 3, 4, 5, 6. I'm going to do the first one. 0, 3, right there. 6, 0, right there. And I'm going to take a straight edge. Again. That's the benefit of this. I can use a straight edge. Well, it's scratching good. Okay. Extend them. The next one, 0, 5. 1, 2, 3, 4, 5. And 3, 0. 1, 2, 3. Let's extend it. And then we'll figure out which direction. Shade. Now, how do we check which direction to shade on these constraints? I haven't done the objective function yet. I want to find that feasible region. We pick a dot on either side of the line, fit it into the constraint, see if it's true or false. If it's true, that's the direction to shade. My favorite point on a graph to use is 1, 1. It makes it so easy. So the first one we did is this top one up here, the A and the B equals 6. I'm going to use 1, 1, which would be this direction. And if you take 1 in for A, 1 for B, 1 times 2 is 2, plus 1 is 3. Is 3 less than 6? It's true. So this one right here will be going this way. Now, I should be shading right here, but I know it's not going to be part of the feasible region, so I'm already leaving it off. But, I don't know, I'm just showing it. There we go. The other one now, I'm putting a 1, 1 for there. 1 times 5 is 5. 1 times 3 is 3. 5 plus 3 is 8. 8 is less than 15. The shading is that direction for that one. I'm going to do the shading a different way. And now, where the shading overlaps, because these are the only two constraints in this problem, is your feasible region, and anywhere there's two lines crossing, touching the feasible region, is an extreme point. I like to put nice shade in where the feasible region is so there's no mistaking it, right there, and I like to make the lines really dark all the way along the edges of the feasible region to make it clear I've identified it. And I even go FR, and I'll put an arrow right there. There's the feasible region. And I like to put nice dark dots where the extreme points are. How many extreme points do you see? Can't hear you. 4. That's right, 4. Right there at 0, 0. Right there at whatever, 0, 3. This one we don't know. And then right here at 1, 2, 3, 0. There's the 4. So I put extreme points equal 4 of them. All right, now this is a maximized problem. I'm now going to graph our objective function. 0, 4, 6, 0. 0, 4 is right there, and 6, 0 is right there where this other line is. Now when I connect these two, I'm going to make this line wider and darker than the other lines.
Go farther to the right.
Oh, I'm sorry, thank you. Thank you, thank you. Ignore that line. Look at, I'm outside the feasible region, aren't I? So my goal of being across the feasible region did not come true. Now I just got to make it a little thicker so it's obvious. Okay? I have the angle though. But I ended up being outside the feasible region. Now it's a maximized problem, so if I take a point here or a point up here and put it in the objective function gets larger up here. So I know, looking at that angle, that there's no way this 0, 0 can be the optimal solution. I got it down to 3 points. And at that angle, if it were across here, I'd be heading this direction, and I'd be past that point right there, which is 3, 0. So I know that's not the optimal solution. I know it's one of those other 2 points. Now, because my line's outside the the feasible region, I'm going to take my straight edge, keep it parallel, and I'm going to for sure figure out of these 2 points right there, which one is the optimal solution. It'll be instead of the last one that this straight edge will touch, it'll be the first point that this straight edge would touch if I stay parallel, the very first one. You see it? That one, not the top one, is our optimal solution. Optimal solution right there. That's it. Now, I have to go find which lines are forming that point that we graphed. And that point happens to be the less than equal to 6 and the less than equal to 15 constraints are those 2 lines. So any line, it could be one line crossing an axis, or it could be 2 lines crossing each other. Any lines forming the optimal solution are called the binding constraints. These 2 right here are binding. So I've identified them. Again, the binding constraints, if they're involved in forming that optimal solution extreme point, it's a binding constraint. It's the most important constraint. When you have a list of 5, 6, 7 constraints, the binding is the most important of all. There's no wiggle room or it changes the solution. All right. Now that we found that, we would either use, we would take these 2, and we're either going to use the subtraction method, addition method, or substitution method to solve. And as I look at it, first thing I'm noticing is A for both constraints, one's a 5, one's a 1. So if I subtract them, I wouldn't get 0. For B, one's a 3, one's a 2. Again, if I subtract or add them or whatever, I wouldn't get a 0. So I like how A is all by itself, and I wouldn't have to divide by any number. And if I got A all by itself on one side of the equality, then I could use the substitution method by replacing A in the other one. So here I go. I'm going to take A plus 2B equals 6. I'm subtracting 2B on both sides. Whatever you do to one side, you have to do to the other side. And that's going to leave you A equals 6 minus 2B. Now I'm going to plug in what A equals in the other equation for A, eliminating A so we can solve for B. So the other one was 5A, so now instead of being 5A, it's 5 times 6 minus 2B, because I replaced A with what A equals from the other constraint, or the other, constraint. And then add 3B equals 15. I'm going to start with the parentheses. 5 times 6, 30. 5 times negative 2, minus 10B. Plus, still got the 3B, equals 15. I'm going to do 2 steps at the same time here. I'm going to put these like terms together, which are both B's. The negative 10B, add the 3B. And then I'm going to take this 30, subtract it from both sides, put the numbers together. So on the left side, negative 10B plus 3B leaves negative 7B. And when I subtract 30 on both sides, I get equals negative 15. So I get negative 7B equals negative 15. I divide by negative 7 on both sides. I get B equals 2 point, what? What did I do wrong? It's possible. What is 15 divided by 7? Help me out. 2 point what? 2 point what? 9? 5. Thank you. 2.5. We just found half of that point right there. 2.5. You guys give me a look like I made a mistake. Yeah, it looks like it should be 2.5. Should I keep going? That's not 5? Let's help me out. 15 divided by 7. 2.14. Okay. 14. That's what I meant. 2.14. What's the next digit? I want to make sure the rounding is correct. 2. Okay, thank you. You ready? Now I'm going to plug 2.14 into either equation for B, and I'll get the same answer, whichever equation you pick, for A, is what I'll get an answer. So B now, I'm going to use the top one. A equals 2 times 2.14 equals 6. Whoops. That's supposed to be A plus, sorry. A plus 2 times B, which is 2.14, equals 6. 2 times, so I got A plus, what's 2 times 2.4.28? 4.28 equals 6. Subtract 4.28 on both sides. A equals 1.72. Is it? Okay. So that spot right there, even though you swear it looks like it's at 2, 2.5 or something like that, is really at 1.72, 2.14 is our optimal solution. Extreme points, we said there's 4 of them. Feasible region, we identified it with some dark shading and outlined it with some dark borders. Binding constraints, we identified them because they're the ones forming the optimal solution. Now we have objective function value, slack, and surplus. The optimal solution that you just found has to be plugged in to everything. That's the point you're at. You have to plug it into the objective function. You have to plug it into the constraints. When you plug it into the objective function, whatever it equals is the objective function value. That's what we were trying to max. And this is the max we can get it. So, you ready? I'm moving up a little. What's the objective? 2A plus 3B. 2 times 1.72 plus 3 times 2.14. Anybody done this already? No. 2 times 1.72. Give me a number. Don't make me get serious. Say it. Couldn't hear you. Huh? 3.44? Is that what it is? 3.48? Are we doing 2 times 1.72? It's got to end with a 4. 3 point what? 3.44, right? Is that true? Okay, 3 times 2.14, 6, 14, 20, what is that, 30, 40, 42? 42, so 6.42, is that right? Add those together, you get 9.86, does that sound right? That's the largest we can get it to stay within those limitations, maximizing the constraint. That is our objective function value. It's what the objective function equals when the optimal solution has been placed in it. Now we got to do the constraints. Every constraint. If you've got 5 constraints and it says solve it graphing, you've got to put the optimal solution for A and B or whatever the variables are into every constraint and see if the left side equals the right side or not. And if it doesn't equal, when you put the optimal solution in and the left side doesn't equal the right side, you just found either slack or surplus. The difference is either the slack or surplus. If the constraint is originally a less than equal, the difference is called slack, period. Let me say that again. When you put the optimal solution into each constraint and the left side doesn't equal the right side, you found either slack or surplus. If the constraint is originally a less than equal, call it slack, period. That's what it is. And obviously, if the constraint is originally a greater than equals, you just calculated the surplus. Now, I need to make sure you can always identify whether it's slack or surplus. So, for just this chapter, on your homework, on your in-class, I don't know, not on your in-class, but on your quiz, you're going to be asked to calculate the slack or surplus for every constraint and name whether it's slack or surplus, even if your calculation comes to 0. Everybody hear that? Which means it has no slack or surplus. You still need to show me 0 or no, and then the word, either slack or surplus. Showing me you identify that you realize it would have been slack or surplus. Everybody hear that? Because you looked at the original constraint, and you said, oh, it's a less than equal, 0 slack. Or it's a greater than equal, 0 surplus. Now, if you remember this, you have a shortcut for whatever constraints are binding. Because every binding constraint is always 0 slack or surplus. No matter if it's a less than equal or greater than equal, if it's a binding constraint, it has no slack or surplus. And I will allow as an answer for that constraint for slack or surplus, you don't need to plug in the numbers if you remember the shortcut, and you just need to stay, since this constraint's binding, it has 0 slack or surplus. You don't have to show the calculation, just say, because it's binding, it has 0, and then put the word slack or surplus based on whether it's a less than or a greater than. So in this case, both of these constraints are binding, so you can literally write constraint less than equals 6 is a binding constraint, therefore it has 0 what? Slack or surplus? Slack, because it's a less than equal. Get it? But let's put the numbers in just to prove it. A is, 1.72 plus 2 times 2.14 less than equal to 6. Now, 2 times 2.14, have we done that already? We didn't. What is that? That's 4.28. So now, 4.28 plus 1.72 is 5.9, that's 6 less than equal to 6. So then you put 0 slack. You're saying there's none because both sides are equal, there's no difference between them, and it's slack because it was a less than equal. There's points in just saying slack because even though it has none, you're identifying it would have been slack. I'm able to see that you can recognize because it was a less than equal, it would have been slack. The other constraint, I'm going to take the shortcut. What is it? The less than equal to 15 constraint is binding. Therefore, I don't know, you can say it how you want. Therefore, it has 0 slack. Again, I put the word slack because I realize it's originally a less than equal. Is that everything? select, surplus, objective function, binding constraints, feasible region, extreme points. All right. The good news is, when you get past this next quiz, you'll never have to graph again. And you'll have the fundamentals to understand how all the other answers for the rest of the semester came about, but you don't have to do it. You just now know how it's done.
How do you tell what the binding constraint?
You ready? The binding constraints are whichever lines that were formed to cross to make that optimal solution.
Okay.
Once you find the optimal solution, you got to recognize which equations are those lines, and then you got to use either the addition method, subtraction to figure out what that point is. Those constraints that you're either adding or substituting or subtracting are the binding constraints because they're forming the optimal solution.
There will always only be two, right?
No, there could be one. It could be crossing the axis. That extreme point right there would only have one binding constraint. It is possible, but rare, where three lines are crossing at the exact same point. You could have three binding constraints, all with zero select or surplus. So don't rely on there always being two. It's very common to have two. That's most common. Any other questions? Because I think we're almost done with chapter 2. We're jumping to software. Are you ready? Everybody? Okay, can you grab? Because you have one to do on, what, Wednesday. You're doing everything we just did, just like that. Right? Next, let's go software. Anybody, if you bring let me see here, where's it at? Flash drive or something, if you want to just do this. And by the way, I would just run it off the flash drive. I would not install it on my computer. That's what I do. It just seems to run a lot better after you get past the first time. Let's say you have your pen drive open or your flash drive, and there's the folder I transferred called Management Scientist onto your flash drive. Open it up. And here's how you would install it. This is what I'm skipping. I'm not doing the setup. I'm going to run it right off the flash drive. And you go right down here into the executable file, and you double click on it. Now, the first time, you will most likely get an error message. Get rid of the error message, get back to it, right click on it. You only have to do this the first time. After that, it'll work, just double clicking on it. Right click on it, left click on Run as Administrator. It will come up with this thing, say yes, and then it will run, and you shut it and reopen it every time. It will work after that. It's just the first time, usually. Unless you have a Mac. You may have to get on the internet and start reading a special way to make it run on your Mac. I can't remember what you've got to install. I know it can be done, but I think it's a lot of work. You've got to be tech savvy. Or you could use Lab Anywhere, which we've gone over in this class, and you could just use the lab computer. When you get to the choices of the lab computer, don't pick the Windows 10. It's the other one that has the software on it, not the Windows 10. Okay, so let's say I already did Run as Administrator. Now I'm going to use it again. Just double click on it. It opens up, looks like that. Say Continue. Which module are we using here? We're going to solve the problem we just did using the software. It's a linear programming problem we just solved. Number 1. Now, first you say File, New. The number of decision variables in that problem. How many decision variables were there? That's right, 2. How many constraints were there? 2. Max or min? Max. Now, when this opens up, there'll be 2 variables and 2 lines for constraints information. It always assumes it makes it x1, x2, x3, x4, however many variables involved. I like to change it to whatever variables are being used in the problem. You don't have to. It's up to you. So I'm going to double click on or click on that one, make that an A. When I click out of there, it will change the bottom one as an A. Come on. There it is. I'm going to make this one a B. When I click out of there, I'll make the bottom one B. So now I'm using A and B. Here's the objective function. What number is with A in the objective function? 2. What number is with B? 3. Let's go to the first constraint. What number is with A? There's no number, which is the same as 1. If there was no A, what number would I put? 0, or leave it blank. It will assume 0 if you leave it blank. But you can put 0. B in the first constraint, what number is with? Is it 3 or 2? 2? And then, okay, you do not put less than equal. Every constraint has equal involved, and it's always assumed. You either type the less than or the greater than, and if it's a rare circumstance, it's a true equal constraint, you type an equal. This constraint is less than equal, so I'm just going to type the less than. You don't have to do the equal. And then the right-hand side is a 6, is that correct? All right. Second constraint, what number is with the A? Is it 5? Okay, B, 3, and it's a less than, is that correct? And the right-hand side is 15. Okay, is that everything? We're now going to hit solution. You're about to see what the output looks like. Now, what you're about to see output is not exactly the same way the output's in your books. Not the same way that's a different software. Every software gives the output a different way, but it's the exact same information. And once you get used to the kind of information you're going to see on this output, you'll be able to read any of the other outputs as long as you know what you're looking for. Sometimes it's just described slightly different, but they all give you the same output. Solution, solve. At the very top is called the objective function value, 9.857. If we were to put the optimal solution into the objective function, that is what it would equal. And we calculated it to be 9.86. Right? Right there where it says variable A and B value, this is always where your optimal solution is. These are truly what A and B are when they cross right there where those two lines cross. 1.714, we used 1.72, so we rounded up instead of down somehow. And 2.143, we used 2.14. Now, go down, constraint 1, slack surplus. Notice it has a 0. Don't go to the right, dual prices. We're not there yet. That's next chapter. Slack surplus, you see a 0. Constraint 2, slack surplus, 0. In your future, third quiz, I think it is, or your final, you're going to get a problem that says, look at this output, identify the binding constraints. You jump right to that section, you find the ones that have 0 slack or surplus, because only binding constraints have 0 slack or surplus. They're the ones crossing at the optimal solution. And if you have a question that says, what are the binding constraints? And you don't remember this, you're going to go, well, I got to have the original problem. How am I going to figure out the binding constraints? Because you forgot, on the output, you'll find slack or surplus, no matter which software you're using, it's somewhere on there. The ones with 0 are the binding constraints, constraints 1 and 2. Look at variable A. In the objective function, you told me the number with it is a 2, and with B is a 3. Now this is a very common occurrence. Let's assume that this is, $2 profit for every widget and $3 for every big widget, supreme widget. And all of a sudden, that meeting you had where you all talked about what's involved in the process, what our supplier costs are going to be, what we're going to sell it for to our distributors, and you came up with this profit. And someone comes to your office and goes, oh, you aren't going to believe this. The supplier just got a hold of me and said he or she gave us the wrong numbers. And we're going to be able to get a better price on the supreme widget and the regular widget. And our profit's going to go up 25 cents on the widget. Now, you know what? Our profit's going up $1 on the widget and $1.50 on the supreme widget. Let's just talk about the widget. Our widget's going up $1. We thought it was going to have a profit of $2. If it's going up $1, it's going to be at $3. Do I have to redo this whole thing, or can I make a quick decision right there and say to them, don't change production, our optimal solution is still 1.714 and 2.143, or do we have to redo this whole thing? Say that? We don't have to do a thing. The optimal solution is still valid because that increase of $1 takes it to 3, and this output's telling us that could increase all the way to $5, and that optimal solution is still valid. Make the decision. The 3 is going up $1.50 to $4.50. Forget the other one. Only one of these are happening at a time. Is the optimal solution still valid? Very good. Because that increase takes it to $4.50 from 3, which is outside the upper limit, which is telling you, hold production up. Because we're already into production. Stop production. I got to quickly redo this whole problem. You got to remember, there's probably 30 constraints, 10 variables. You need to get whatever changes involved, get it in there, get your new optimal solution, and then get production back on going again because something's going to change. The optimal solution is no longer valid because of that, what just happened. And that's how this output really becomes handy, especially here. This is where the more common decisions have to be made quickly, because this represents usually like raw material coming in from a supplier or something. This was 6 tons, 15 tons maybe. And we scheduled everything based on the order that we had in place of 6 tons and 15 tons of this raw material. But all of a sudden the company called and said, look, we're about to deliver your material, or you started production even. Hey, we have a truck in your area. I know we dropped off your 6 tons already, but we have an extra ton, and it's blanky blank price. Chapter 3, the price matters, but it's blanky blank price. First of all, can you use the extra ton? Can you tell me right now why you say yes?
Because it's lower than
That's right. We could use up to 4 more tons, and our dual price, which is chapter 3, is still valid, and I can make a decision right now while you're on the phone whether I'm taking that or not. What's that price again? You'll learn that in chapter 3. Do you see where I'm going with this, though? This is how this is used in real life, in real business. You've got to get that optimal solution and be ready to make decisions if something changes. And something does change. Probably every, if your cycle's a weekly schedule, probably every 3 to 4 weeks, something changed that was unexpected, and you quickly got to make a decision. And that's where this output comes in. This is a very micro-simplified version of what I'm describing to you, but I'm just trying to get you to understand how this is really used and the gist of it. You ready? Excel. I posted this, and I just want to show you how it can be used no matter, as long as there's 5 variables or less, or it can be used no matter what. You just got to make changes to this instead of redoing it every time if you want to use Excel. By the way, on the quiz, even though I'm saying solve this graphic, if you have the software and you want to check your answer in the software while you're taking the quiz, you can do that, even though all the points are in the work getting to that answer. Or you can use Excel and check your answer if you want. And we're heading to where you need to be able to use Excel or the software to get to your answer. This is like the end of where you're not using Excel or the software to get an answer. That we're all getting an answer by hand. We're getting to the end of that at the end of this chapter. So, you're going to have to tell me the numbers again on the problem. First of all, we had only 2 constraints, right? So I'm going to eliminate this third one by just saying delete. Whoops. Wait, what did I just do? Not open. There we go. Delete that row. There we go. And my formulas probably changed with it, I'm assuming. And then the numbers. Hang on, I got it right here. Constraint 1 has a 1 and a 2. Whoops. Watch, I'm going to change these to A, B. I'm going to leave the rest of those blank because we only have 2 variables. How am I doing on time? We're okay? B. And then the right-hand side, it happens to be a 6 here. This one's a 15. And the left-hand side is a 5. And what is this? A 3. The objective function numbers, it's a 2 and it's a 3. Okay, there's my inputs. Just like the software, you had to input the numbers for each variable for the constraints and the objective function that are with them. Now here you leave these 0. This is where your optimal solution is going to appear. We only are going to have an answer here and here, but all that's there is a 0 because you're going to tell the Excel that's where you want the optimal solution placed in those 2 cells or however many variables you have. Here's where you got to make sure your formula is correct. The objective function, before I go to this, is if we were to place the optimal solution for A and B in the objective function, it would be 2 times 3 times added together. So this has to represent 2 times whatever that equals, plus 3 times whatever that equals, using cell locations, not numbers. So it's going to be, what is that? E9 times E13, let me show you. E9 times E13 plus F9 times F13 gives you the objective function value, which is what we were doing by hand. The left-hand side, this right-hand side, this probably says, what is that, J7. That says J7, so that will change whenever you're putting in a new constraint here. And this says J8. And this has no reference because I only have 2 constraints. I didn't get rid of this. Let's get rid of that. Whoop, whoop. There we go. Here, before I click on this, let's recall how we would do this. We would put the optimal solution for A, the optimal solution for B, do the math on it. So using cell locations, see, the optimal solution times the A, the optimal solution times B, added together, using cell locations. Here we go. E7, where the 1 is, E13. F7, F13. Tell me this next one now. Tell me what this says in it. Someone jump in. E8, very good, times E13 plus F, no, 8 plus, I'm sorry, times F13. Sure enough, you got it. E8, E13, F8, F13 added together. We're just going to look at these. And I would even put a formula out here that says, is this different from this? And give me the difference. And I put an if formula there that determines whether it should be slack or surplus. If this symbol is a less than, put the word slack. If this symbol is a greater than, put the word surplus. Something like that. Here we go. We got our formulas in. I'm going to follow the steps on page 89 like this says on there, step by step. It says go to your data tab, go to your solver. Again, if you don't have solver, I said it helped. There's all kinds of instructions all over the internet how to install it. It's real easy. You're going to get rid of all this. Hang on, pretend you can't see this. Hang on. This is what it'll look like the first time you open it, right there. Now, take good notes. The word set objective means where is the optimal or objective function value being calculated. You're going to forget that. And this could be exactly what a problem on your quiz looks like, a picture. And it will say, what would you put as the set objective if you were using solver? And you would want to put what cell location is the objective function value being calculated? E15. So I'm gonna, instead of writing E15, I just click on it. It puts E, a $E, $15. You don't have to have dollar signs, but you should. Then, max or min, click max. Then it says, by changing variable cells. Put in your notes, the words by changing variable cells is the same as where do you want the optimal solution placed? What cells are we putting the optimal solution in? In this case, it's E13 and F13. So I just, instead of typing E13 and F13, I just have my pointer blinking right up there in that spot. I left click and hold my click down and drag, and there it is, E13 colon F13.
Does the order matter?
Does order matter?
So if you click on...
I think it will automatically put it in, no matter what order I click on and drag, it will put it in the order you see now. Let's test that. Let's test it. Why not?
So like we did like...
Even if I drag from here, it's going to still be E to F.
I'm saying if you're not dragging, if you do like...
Oh, I don't know. I've never not dragged. Hang on. There. And then how do I get the other one? Control click? Right here? Yeah. No, and then it's got a comma. Yeah, I guess it could do that. You'd have to do each one.
Yeah.
Yeah. If I drag it, then it would say, like, if I had 5 variables, it'd be E13 through EFGHI13 or something like that. So we'll try it this way. I've never done it this way with a comma, but let's see if it works. So I clicked on E13, held Control, and then clicked on E14, or F13, excuse me. Okay, constraint. Now there is a shortcut to do this. I'm going to do it the long way. I'm going to add a constraint. It says cell reference. Cell reference means where is the left side of the constraint being calculated at? Where is that at? And for this constraint, it's right there at E19. You go to the center and pull down. Is this a less than equal, greater than equal, or equal? I click less than equal. And then constraint means the right-hand side of the constraint. Where's the cell location where that is? And that's right down here at J19. And then I say OK. And there's that constraint. E19 less than equal to J19. I'm going to do another one. Left side, this one is E20. Open this up, less than equals. The right side is in J20. Does that look right? E20, J20? Hit OK. There's both constraints. That's all there is at this point. You have to make sure that this is clicked, non-negative variables, which reminds me of something. Every one of these problems has this at the end of them. Did I already talk about this in this class? You'll see a lot of them say x1 comma x2 greater than or equal to 0 at the end of the constraints. For this class, you never have to do that. You don't have to, you can ignore it. It just says that the decision variables will always be positive numbers or 0. It will never be, we're not going to make negative cars. Hey, we're scheduled to make 5 cars for the week schedule. We can't designate -5. Take apart 5 cars. It's not ever going to happen. The variables are always positive the whole semester. So you always want to click non-negative. Unconstrained variables, non-negative. Always. Then you want to open this up and click on simplex linear programming. LP stands for linear programming, which is what we're doing, the simplex method. Now when I click solve, it's going to happen like in a split second. It goes really fast. And then your optimal solution will be here, your objective function will be here, the left-hand side of these will be here. It'll say, okay, yes. 9.857143 is our objective function value, as high as we can get it. A's optimal solution is 1.714. B is 2.143. All right? Right? The left-hand side of the first constraint is 6. The right-hand side is 6. If we did this, it would say 0. And then we'll say slack. So we'll look here, if statement would go, oh, we would manually type this in, by the way. This is just for looks. I had to type that. But I didn't have it. If I knew I had an if statement there, I'd always put a less than or a greater than symbol here representing that constraint, so that would work. 15 is equal to 15, 0, slack. That's equal less than equal. That's how you use Excel. You can now use the software to solve these. You can use Excel. Boy, this class is too easy. Man. You guys never thought it'd be this easy. Okay, let's do our in-class. You know the routine, right? The first 7 of you, I want 2 signatures that you went to another part of the room and helped 2 people. Everybody hear that? You went to another part of the room and helped 2 people. Then after I yell 7 are in, the next 7, you only have to go around the room and help 1 person in another area of the classroom. And then after those 7, just get it in. You ready? You can have, you're all going to get the same answer, but your work could be completely different than another person. So try to help them whichever way they want to answer it, because you can use any of the 3 methods to take these 2 constraints and find where they cross if you were to graph them. Now you don't have to graph them, don't get confused. You only have to take it to the step you've already identified the binding constraints of these 2. Your next step is to find where they are crossing. Use any of the 3 methods you've been taught. Everybody with me? Anybody lost? Is that it? Really? This class flies by.